Next, here we have C, H, and O. This is ethanol. And we have oxygen, and then over here we have carbon dioxide and water. This is a combustion reaction. The hydrocarbon can also have oxygen in it in order to be in a combustion reaction. Down here we have number 4, we have lead and H3PO4. And so what's going to happen here is the lead's going to come over. We have element plus compound yields different element and different compound. And so of course this is going to be a single displacement reaction. Up here we have 2 hydrogens and 6 hydrogens and 3 oxygens. Over on this side we have 1 carbon and we have 3 oxygen and 2 hydrogen. So let's get started. Carbons don't balance, hydrogens don't balance, but we always save hydrogen and oxygen till last, remember, if we can. So I'm going to fix the carbons first, and so I'm going to put a 2 here, and that will give me 2 carbons, and it will give me, let's see, 2 times 2 is 4, 5 oxygens. Oh, I hate when that happens. Okay. So 5 oxygens over there. So what we're going to do next is look at the, I don't know, hydrogens, I guess. There's 6 on the reactant side. There's 2 on the product side. So I need 6 over here, so I'm going to put a 3. So 3 times 2 on this side, on the product side, gives us 6. And we have then 4, 7. So we still have that odd number there, which nobody ever likes. So we have got to mess with the oxygens. If we change just the O2, the number of O2 molecules, we're never going to get an odd number. So what I'm going to do is I'm going to go ahead and I'm going to put a coefficient 2 in front of there. And that's going to give me 2 times 2 is 4 carbons, and there 5 times 2 is 10, 11, 12 hydrogens. Here I have the 5 times 2, and then we have the 1 times 2, which is where the 12 comes in. 10 plus 2 is 12. And then for the oxygens, we now have 2 oxygens in ethanol, and over here we have 2 more, and so that's going to be 4. Okay. And so let's see, how are we doing now? Okay, now our carbons aren't working well. So let's do those. We always try to do those first. There's a rule erase lines. Go ahead and erase that. And so here I have 4, so I'm going to put a 4 here. And that's going to give me 4 carbons. 4 times 2 is 8. 11 of these. And let's do hydrogens next. Oh, we're going back and forth here. So there's 12 hydrogens on the reactant side. We only have 6 over here. So I'm going to erase that. And we want 12, so I'm going to put a 6 here. And that is going to give me 12 hydrogens. And over here we're going to have 4 times 2 is 8. And then plus 6 is, I believe, 14. Okay, so now I have carbons balance and hydrogens balance, but our oxygens don't. The good news is 14 is an even number, so I can put 6 in front of here, because 6 times 2 is 12, and then I have 2 more from over on this side, from over in this compound, which will give me 14. That was a little complicated, so let's make sure we go back and check. On the reactant side, we have 4 carbon. Product side, we have 4 carbon. On the reactant side, I have 5 times 2 is 10 hydrogen, and 2 more for 12. Over here, 6 times 2 is 12 on the product side. Oxygen, I have 2 oxygen here, and then over here, 6 times 2 is 12, that's 14. Oxygen here, 4 times 2 is 8, plus 6, which is 14. Okay. Word equation for that. Now, as I said, this was 2 molecules of ethanol plus 6 oxygen gas, or diatomic oxygen, yields 4 molecules of carbon dioxide and 6 molecules of dihydrogen monoxide, or water. Okay. Then over here, we're starting out with 1 lead, 3 hydrogens, and 1 PO4 on the reactant side, and 3, 2, and 2 on the product side. So let's go ahead and fix these. I'm not going to mess with the lead at this point because it's all by itself over here, so we can do just about anything to it. And then the hydrogen, same thing, because the hydrogen is as an H2 here. So I'm going to go straight down and I'm going to do the phosphate. I have 2 phosphate on the product side and only 1 on the reactant side, so I'm going to put a 2 here. And that's going to give me 3 times 2, that's going to give me 6 hydrogens. It's going to give me 2 phosphates. Okay. Well, let's see. So my leads are still off, but I'm going to again leave that. My phosphates balanced now, so over here I am going to put a 3 times 2, that's going to give me a 6. And then I'm going to put a 3 here, which will give me 3. And let me check. I have 3 lead on the reactant side. I have 3 on the product side. I have 2 times 3 is 6 hydrogen, and 3 times 2 is 6 hydrogen on the product side. I have 2 phosphates and 2 phosphates. This is our single displacement reaction, as I said. This would be 3 atoms of lead plus 2 hydrogen phosphate, or phosphoric acid if we wanted, to talk about the acidic form. Yields 3 molecules of diatomic hydrogen plus 1 formula unit of lead 2 phosphate. And it's lead 2, remember, because the lead has a +2 oxidation state, phosphate has a -3. We did the switcheroo.